Welcome you all my lecture series of data structures. In today's class we are going to see about the how to represent the graph in terms of an array and linked list. In the previous video all we know that what is a graph and what are all the basic terminologies we have to need to represent the graph. Next is a graph representation. As it is the other data structures like stack, queue and tree, there is a representation of these data structures either by the array and linked list. So the same terms the graph is also used to represent. So I recap that what is a graph. Graph is a collection of vertices and edges. It is called it as a graph. So in the graph we have a degree. Degree is a number of edges connected to a vertex is said to be a degree. So these basic terminologies already we have seen about in the previous video. The representation of the graph is either is an adjacency matrix representation or the linked list representation. So adjacency matrix either for the we can represent the adjacent graph in terms of an adjacency matrix for either a undirected graph or directed graph. The given example, this is an undirected graph. So now we are going to represent that undirected graph in terms of an adjacency matrix representation. So adjacency matrix is nothing but it is a combination of the rows and columns. So for example, we have a number of vertices is in this graph is 4 means. So every rows and it contains a 4 by 4 rows and columns. So what are all the vertices names? 0, 1, 2 and 3. So you mark it as a rows and columns as a 0, 1, 2, 3 as an vertices. Now we fill the matrix in terms of an adjacent. For example, for the node 0, what are all the adjacent vertices of 0? 1 and 3. So that 1 and 3 spaces we mark it as an 1, remaining vertices we mark it as a 0. For each row we are representing like that. For 0th vertex, so the 0 is there is no self loop, so there is a for the 0 contains a 0. Next is that for the from the 0 the adjacent is 1 and 3. So for that adjacent name 1 and 3 we mark it as an 1. Next go to that node 1. So what is a that is also does not contain a self loop. So the adjacent of 1 is 0 and 2. So for that 0 and 2 spaces we mark it as an 1. So on the remaining spaces we mark it as a 0. Next is a 2. So the adjacent of 2 is 1 and 3. So mark it as 1 and 3 space 1 for that 2 node, remaining is a 0. Next is a 3. So in the 3 the adjacent is a 2 1 0. So mark it as 1 for node 2 1 0 in the fourth row. So this is an adjacency matrix for the undirected graph. Suppose we have a directed graph. How to represent the adjacency matrix means, so the adjacent of 1 is 1 comma 2. Adjacent of 0 is there is no outgoing edges, that is a 0. So the adjacent of 0 is 0 for all the remaining nodes. Next is 2. So the adjacent is for the directed graph is based upon the incoming edges. Okay, so adjacent is based upon the outgoing edges. For example, in here the node 2, how many outgoing edges? We have only one outgoing edges to 1. So the adjacent of 2 is 1. So that one node we mark it as an 1. Next is the adjacent of 3. So the adjacent of 3 is 1. So the adjacent of 0 is 1 comma 2. So this is the representation of adjacency matrix for the directed graph. So in the directed graph the adjacency matrix they represent the adjacent as a outgoing edges from that node, that is an adjacent of particular node. Next is a graph's adjacency list. In terms of a linked list we can represent the adjacency. For example, this is an undirected graph adjacency list. We can mark it as an linked list concept in terms of a directed graph also. For example, adjacent of 0 is 1, 2, 3, 4. So from 0, we have 3 adjacent nodes 1, 2, 3 and 4. For every node, like a linked list, for every node we have a data part and linked list part. So the same terms we are using here also. Next is for adjacent of 1 is 0, 3. So the adjacent of 3 is 0, 1 and 2 and 4. So adjacent of 3 we are having the 4 adjacent of 3. So the linked list contains the 4 nodes. Next, the adjacent of 4 is 0, 2 and 3. So because it is an undirected graph, so the adjacency of 4 is also 3 vertices. So here the representation of the graph in terms of a linked list, here in terms of an array. Adjacency matrix. So the representation of graph in ketangana, that is a 2 types of representation. One is a adjacency matrix, other one is a linked list adjacency list matrix. I hope you will understand how to represent the any graph. It is an undirected or directed graph. You can represent either in terms of a adjacency matrix or adjacency list. Thank you.